Hi class, this lecture is going to conclude your chapter 2 study, and in this lecture what we're going to do is we're going to go into section 2.7 and talk about proving theorems about angles. So we really just have this one objective in this section, and this is to prove and use theorems about angles. Alright, so when writing a proof, it's often helpful to take a moment to write the statement in if-then form. This helps identify the given information and what we want to prove. So the given is the hypothesis, all right, following the word if. So what we want to prove is that conclusion following the word then. So let's begin our proofs with a few theorems about complementary and supplementary angles. All right, so this is going to be a theorem called the equal complements theorem. And complements of the same angle or of equal angles are equal in measure. So what that means, if angle 1 plus angle 2 is equal to 90 degrees, then the measure of angle 3 plus the measure of angle 2 is equal to 90 degrees. Well, if you have this and then this, so if this, then this, well, if these two are part of the same statement, then it must be that the measure of angle 1 is equal to the measure of angle 3. So that's the equal complements theorem. And you can just notice here, like, obviously, just by looking at it, it would make sense that measure of angle 1 and measure of angle 3 would have to be the same. All right, also, you could have the equal supplements theorem. So complements of the same angle are equal in measure. All right, so with supplements, if the measure of angle 1 plus the measure of angle 2 is 180, then the measure of angle 3 plus the measure of angle 2 is also 180 degrees, then the measure of angle 1 must be equal to the measure of angle 3. Kind of like the same idea. If these two are equal, then this and this have to still be the same, and it's equal 180. All right, so let's do a problem. So this is proving the complements theorem. So if measures of angle A and B are complementary, and measures of angle C and D are complementary, and the measure of angle A is equal to the measure of angle C, let's prove that the measure of angle B is equal to the measure of angle D. So here's what we're saying. A and B are complementary. That means they sum up to 90. C and D are complementary. They sum up to 90. And we also know that measure of angle A and measure of angle C are congruent or are equal. So we've got to prove then that by extension, measure of angle B is the same as measure of angle D. All right, so let's start with our two columns proofs. So statements, we got measure of angle A and B are complements, measure of angle C and D are complements. That's a given. Measure of angle A is equal to the measure of angle C. That's also given. Well, then what we know, since they're complement, measure of angle A plus measure of angle B is 90. Measure of angle C plus measure of angle D is equal to 90. That's the definition of complementary angles. We can sub in here. Notice that I have measure of angle A plus measure of angle B is equal to, and I'm just replacing it with the measure of angle C plus the measure of angle D. So where that was at 90, it's this. And that's that transitive property that we learned back in section 2.6. All right, it's just really if two things are equal to the same thing, then these two must be equal. Finally, replacing here the measure, notice I'm going to replace the measure of angle C with the measure of angle A from up here. That's just the substitution property. I'm just subbing it in, replacing it. So then, by extension, the measure of angle B must be equal to the measure of angle D. And that's because what I'm going to do is I'm going to use the subtraction property of equality and subtract away the measure of angle A from both sides. And that's what I was trying to prove, that the measure of angle B is equal to the measure of angle D. All right, let's talk about the linear pair theorem. So if two angles form a linear pair, then their angles are supplementary. So linear pairs means the two angles that on each side here, right, sum to 180 degrees. So the measure of angle 1 plus the measure of angle 2 has to be 180 degrees. All right, so let's do a problem. So given angle 1 and angle 2 form a linear pair, prove that angle 1 and angle 2 are supplementary angles so that they add up to 180 degrees. Well, this one's a little bit harder. So angle 1 and angle 2 form a linear pair, given. What we would say then is ray BA and BC are opposite rays. So this ray and this way are opposite rays, and that's by definition of a linear pair. Points A, B, and C lie on the same line between B between A and C. That's just the definition of opposite rays. We can see that angle ABC is a straight angle. That's by definition of a straight angle. That means the measure of angle ABC is 180 degrees. That's by the definition of a straight angle. So angle 1 plus angle 2 must equal the measure of angle ABC. All right, that's by the angle addition postulate, that this angle plus this angle equals that angle. All right, the measure of angle 1 plus the measure of angle 2, I replace measure of angle ABC with 180 degrees, and thus angle A and angle B are supplementary by the definition of supplementary angles. So this one had a lot going on here. I don't think that the left-hand side is the hard part. It's just understanding what definitions you're using is the hard part. Let's talk about the vertical angle theorem. So vertical angles are congruent. So if you have two lines intersecting like this, the angles opposite each other are congruent. So angles 2 and 4 are the same, and angles 1 and 3 are the same. All right, so given that angles 1 and angle 3 are vertical angles, let's prove that they must be congruent. They must have the same length. All right, so we're given that angles 1 and 3 are vertical. That's a given. What we see here is angles 1 and angle 2 form a linear pair, and angles 3 and angle 2 form a linear pair. So let me go back to that. Angles 1 and 2 form a linear pair, okay, because they sum up to 180. Angles 2 and 3 form a linear pair because they sum up to 180. Excuse me. All right, that's the definition of linear pairs. Angles 1 and angle 2 are supplementary, and angles 3 and angle 2 are supplementary. All right, that's just by the linear pair theorem. Thus, it must be, because if they're supplementary, they sum up to 180, that it must be, if they're both supplementary and they have the same angle in it, then the other two angles, angles 1 and angle 3, must be congruent. And that's that equal supplements theorem. Another way we could do some proofs. So the paragraph proof is a form where the proof is written as a paragraph. So instead of this two-column proof, right? So let's give you some theorems. Right angle congruent theorem. All right angles are congruent. Means all right angles have the same measure. So angle 1 and angle 2 are right angles. Let's prove then that angle 1 is equal to angle 2. So you could write it like this. Proof. Angle 1 and angle 2 being right angles is given. By the definition of a right angle, measure of angle 1 is 90 and the measure of angle 2 is 90. By the transitive property, since both angles are equal, it is true that the measure of angle 1 is equal to the measure of angle 2. So the key there is using the transitive property. Then the measure of angle 1 is equal to the measure of angle 2 by the definition of congruent angles. Equal supplementary theorem. All right. Two equal supplementary angles are right angles. So if angle 1 is equal to angle 2 and the measure of angle 1 plus measure of angle 2 is 180, then angle 1 and angle 2 have to both be right angles. So let's find the value of x here. Let's use some of these theorems. So this is using the vertical angle theorem. So the angles are vertical angles and thus they're equal in measure. So you would just set them equal to each other, subtract the 3x over, divide, and that would be the measure of each angle right there. And that's it. So good luck with your proofs this week and your second journal assignment class.